The story of industrialization has always been about transformation, and today we stand at a moment where the next great leap is underway. The first industrial revolution was about mechanization, machines powered by steam engines that replaced human and animal labor. The second was about electrification and mass production, reshaping entire economies and societies. The third was digital, driven by computers, automation, and global connectivity. Now, the future we are stepping into is not merely an extension of these earlier revolutions, but a complete reimagining of how industries function. We are moving from mechanization to digitization, and that transition will redefine everything we understand about production, efficiency, and progress. Unlike the factories of the past that focused on physical output alone, the factories of the future will be defined by intelligence. Every process, from the movement of raw materials to the assembly of final products, will generate data. This data is no longer a byproduct of work. It is the most valuable resource an organization can own. Imagine a manufacturing plant where every machine, every sensor, and every robotic arm is connected in real time, feeding streams of information into digital systems that not only track performance, but also predict failures before they happen. This is not about fixing breakdowns faster. It is about ensuring breakdowns never occur. That is the power of digitization. Digital twins will play a central role in this transformation. A digital twin is a virtual replica of a physical system, whether that is a machine, a production line, or an entire factory. Through this model, industries can simulate scenarios, test improvements, and anticipate risks without ever disrupting the actual system. It is the difference between reacting to challenges after they occur and rehearsing solutions before they ever appear. The implications are profound: reduced downtime, optimized efficiency, and innovation without unnecessary risk. Another defining aspect of digitization is the integration of cyber-physical systems. These systems blur the boundaries between the physical and digital worlds, creating environments where machines not only act but also communicate. Imagine conveyor belts that can signal when they are overloaded, robotic arms that can adapt to variations in raw material, or logistics systems that reroute deliveries automatically when traffic conditions change. This is a level of adaptability and intelligence that mechanization alone could never deliver. The broader economic and social consequences of this shift are equally significant. Mechanization created scale, but digitization creates speed. In the old model, industries could take months or years to adjust to new demands. In the digitized model, factories can pivot almost instantly. During global crises, supply chains can be reconfigured in real time. During spikes in consumer demand, production can be adjusted seamlessly. Industrialization is no longer a slow, moving machine. It is becoming a living, breathing network. The essence of this new industrial age is not about replacing machines with smarter machines. It is about creating an ecosystem where technology, people, and processes are interwoven in ways we have never seen before. From mechanization to digitization, we are not just building better factories. We are building intelligent organisms capable of learning, adapting, and evolving. This is the future of industrialization, and it is already unfolding before our eyes. Artificial intelligence is no longer just a tool we experiment with. It is fast becoming the engine that will power the next era of industrialization. Where machines once relied on human input to determine their purpose, AI is enabling them to analyze, predict, and even decide in ways that dramatically reshape the industrial landscape. This marks a profound departure from the mechanical past. The steam engine gave us power, the assembly line gave us scale, and computers gave us automation. But AI is giving us something entirely new, intelligence woven directly into the fabric of industry itself. Consider the industrial process of decision-making. In the past, managers and engineers would collect data, interpret trends, and then make choices about production schedules, maintenance routines, or resource allocation. This was slow, reactive, and often prone to error. AI changes that equation entirely. Algorithms can process massive streams of data from sensors, machines, and markets in real time. Instead of waiting for a problem to arise, AI can detect subtle patterns that indicate a future breakdown, a shift in demand, or an inefficiency in energy use. In other words, it doesn't just automate tasks, it anticipates needs. This predictive capability is perhaps the most revolutionary aspect of AI in industry. Take predictive maintenance as an example. Traditionally, machines were serviced on a schedule, whether they needed it or not, or they were fixed after they failed. Both approaches are costly. AI, however, monitors the health of equipment continuously, predicting exactly when a component will fail and recommending intervention at the right moment. This extends the lifespan of machinery, reduces downtime, and saves enormous costs. It is a perfect example of how intelligence, not brute force, will drive future productivity. AI also enables industries to move beyond efficiency into adaptability. Traditional industrial systems were optimized for stability. They ran best when conditions were predictable and constant. But the modern world is anything but stable. Supply chains shift, consumer expectations evolve, and global crises can disrupt markets overnight. AI-powered systems excel in these conditions because they are designed to learn and adapt. A factory driven by AI can dynamically adjust its workflows, switch suppliers, or reallocate resources in real time. This makes industries not only more efficient, but also more resilient. Another transformative dimension is personalization. Industrialization has always been about mass production, but AI makes it possible to combine scale with customization. By analyzing consumer data and predicting preferences, AI allows factories to produce goods tailored to individual markets, regions, or even customers, without sacrificing efficiency. This is how we move from the industrial age of one size fits all to an intelligent age of one size fits one. But what makes AI such a powerful force in the future of industrialization is not just its capacity to process data, but its ability to continuously improve. Every cycle, every decision, every adjustment feeds back into the system, making it smarter over time. Just as industries once invested in stronger machines, today they will invest in smarter minds, embedded in algorithms, platforms, and networks. The future of industrialization will not be defined by how many machines a company owns or how large its factories are, but by how intelligent its systems have become. Power, scale, and automation may have defined the last 3 centuries of progress, but intelligence is the defining engine of the century ahead. The future of industrialization cannot be measured by output alone. It will increasingly be judged by its impact on the planet and the societies it serves. In the past, industrial revolutions were celebrated for their ability to produce at scale, but they also left behind a legacy of pollution, exploitation of resources, and environmental damage that we are still grappling with today. The coming wave of industrialization must be different. It can not only be about faster machines, smarter factories, or bigger supply chains, it must embed sustainability as a central strategy. Industrialization will survive and thrive only if it evolves into a force that creates prosperity without destroying the ecosystems that make prosperity possible. Sustainability, in this context, is not a matter of compliance or corporate image. It is becoming the foundation of competitiveness. Consumers are more conscious than ever about the environmental cost of the products they buy. Governments are tightening regulations, introducing carbon taxes, and demanding accountability. Investors, too, are shifting capital towards companies that demonstrate real progress in reducing emissions and waste. This means that industries that ignore sustainability will face more than public criticism. They will risk extinction. Industrialization has always been about survival in changing times, and in this new era, survival depends on aligning growth with environmental responsibility. Energy is the first battleground. Fossil fuels powered the first 3 industrial revolutions, but their cost to the environment has been staggering. The factories of the future will not be coal-fed furnaces. They will be powered by renewable energy sources like solar, wind, and hydro. Already, industries are experimenting with decentralized microgrids, allowing them to generate and store their own clean power. This not only reduces their carbon footprint, but also shields them from the volatility of global energy markets. The long-term winners will be those who embrace energy independence through clean technology. Equally critical is the shift towards a circular economy. Traditional industrial models operated on a linear principle: take, make, and dispose. But that approach is unsustainable in a world of finite resources. The circular model seeks to design waste out of the system by reusing, recycling, and remanufacturing materials. Imagine an industry where products are built with the intention of being dismantled, where raw materials are recovered instead of discarded, and where nothing is wasted. Digitization makes this vision possible, with AI and sensors tracking materials throughout their life cycle and ensuring they return into the production cycle. Sustainable industrialization also has a social dimension. Factories of the future must not only preserve the planet, but also uplift the communities around them. Fair labor practices, safer working environments, and inclusive growth will be inseparable from environmental responsibility. Companies that exploit labor or externalize social costs will find themselves out of step with the values of future generations, who increasingly demand ethical as well as ecological accountability. Ultimately, sustainability is not a constraint on industrial growth. It is the new engine of innovation. By treating energy, waste, and resources as design challenges, industries are discovering breakthroughs that also open up new opportunities. Cleaner processes, smarter materials, and efficient designs are not just good for the environment, they are good for business. The future of industrialization will not be defined by the smoke of factories, but by the clarity of vision, growth that is intelligent, ethical, and sustainable. The evolution of industrialization has always been intertwined with the human workforce, and the next chapter will redefine that relationship in profound ways. For centuries, machines have been introduced as tools to replace or augment human labor. The loom replaced hand weaving, the assembly line replaced artisanal production, and robots replaced repetitive tasks on factory floors. Each wave of industrialization raised the same question: what happens to the human worker? In the future, however, the narrative will shift. The question will no longer be about replacement, but about transformation. The workforce of tomorrow will not compete with intelligent machines. They will collaborate with them. This collaboration begins with the recognition that humans and machines have different strengths. Machines excel at precision, repetition, and processing vast amounts of data. They can work without fatigue, without error, and at speeds no human could match. But machines, no matter how advanced, cannot replicate human imagination, creativity, or empathy. They cannot design a product that resonates emotionally with a consumer, nor can they inspire teams to rally behind a vision. The future of industrialization depends on leveraging this complementary relationship. Machines handle the predictable, while humans shape the new and the unexpected. Skills, therefore, become the cornerstone of this transformation. In previous revolutions, workers had to adapt to new technologies by learning how to operate them. Today, they must go further. They must learn how to think alongside them. This means workers will require fluency in data analysis, digital systems, and AI-driven processes, but also in problem-solving and adaptability. The most valuable workers will not be those who know how to perform a single task, but those who can continuously learn and reconfigure their skills as industries evolve. Lifelong learning will no longer be optional. It will be the currency of relevance. Automation, when seen through this lens, is not a threat, but a liberation. By taking over the repetitive and hazardous aspects of work, machines free people to focus on higher value activities. A factory worker may no longer spend their day tightening bolts, but instead monitor the efficiency of robotic systems, analyze performance data, and suggest improvements. A logistics planner may no longer manually track shipments, but use AI to model future demand and design more resilient supply chains. Work becomes less about doing and more about directing, less about labor and more about intelligence. This transformation also has cultural implications. Industrial companies must rethink how they structure teams, reward talent, and foster innovation. Hierarchies built for rigid processes will give way to agile, collaborative environments where humans and AI-driven tools work side by side. Leaders will need to be visionaries who can inspire people to embrace change rather than fear it, and who can cultivate